For this project, I did all of the rendering in Redshift. It's one of the most popular renderers for at-home Houdini work for a good reason. The integration with Houdini does work really well. It's an incredibly fast renderer if you have a halfway decent graphics card. And perhaps I'll add some additional rendering videos later, perhaps showing you a similar setup in Karma or Mantra or something. But for now, we're just going to focus on Redshift. And there are free downloads available for the demo version that should work fine for all of your rendering in this class if you don't have an actual license for it. And I'm not going to go over the entire Redshift install and setup, but I will point out a few key things to look out for when setting this up. To make sure that Houdini sees your Redshift install, you'll want to go to your houdini.env file, which is typically, at least on a Windows machine, in Documents/Houdini and whatever version you're working with. And in that houdini.env, I've set the path to point to the Redshift bin path, and the Houdini path environment variable is including the path to the plugins in the Redshift folder. And I'm using this variable that will specifically look for the plugin corresponding to the current Houdini version. Just feel free to copy this string exactly as I've done it here. And that means that when Houdini starts up, it's going to look for that Houdini plugin in this Redshift path here. And when you install Redshift, it will install versions of the Redshift plugin for a number of different Houdini versions. And if the specific build that you're using for Houdini doesn't match the build numbers available that Redshift has installed for you, oftentimes you can fix this just by picking the latest plugin that's included in the Redshift plugin versions, and we can copy and paste that. And if we're working with build number 999 for the sake of example, you can just rename this to match your current Houdini build number, and then when you're starting up Houdini version 18.5.999, if that one ever actually exists, then this will find that plugin path successfully. Now once you have Redshift installed and you boot up Houdini, you can verify that a couple of different ways. At the object level, if you type RS, you can see these RS lights popping up for you. That will be an indicator that Redshift is working. It will also add this shelf for you. So if it's not already loaded up, go to the plus and add the Redshift shelf here. I'm going to make this a little bit bigger so that we can see that. And whenever you create a new camera after installing Redshift, it will automatically include the Redshift parameters on the cameras here. Similar thing with geometry objects. If you create geometry, you can see this includes a tab for the Redshift parameters as well. But for existing scenes where you've created these nodes before installing Redshift, you might need to add these parameters with the shelf tool. So if you had already created your camera before installing Redshift, just select your camera, go to the Redshift shelf, and then you can hit this Cam Params button here, and that will add the Redshift parameters to your camera. Similarly, for these geometry objects, you can hit the OBJ params there, and that will add that tab for you. And now, when we're doing our renders, I never point to these objects where we're doing the actual work here. I don't want the render display to be sensitive to whatever flag we've set internally. You can set a separate display flag from a render flag in here, but I find that a little bit unreliable, and shader assignments are not quite as straightforward when you work this way, so I always create new geometry objects just for rendering. So let's create a few of these. I like to always prefix them with render. So we can create one for the environment, and if we dive inside here, you can just do an object merge and point this to obj/environment/out-env. And when you're setting up these render objects, you might want to turn off the display of other objects. So I'll go to hide other objects so that we can see exactly what we're pulling in each of these render geometry objects here. And we can do a similar thing for the creatures and the water. Actually, I'm going to, for now, turn off the display of all of these nodes here so that we can only see the display of our render objects just while we're setting this up. So let's create another one. This one will be for the rocks. Let's dive inside there, do an object merge, point that to obj/rocks/outriverrocks. This is why it's really important to always create those descriptive nulls at the end of your networks. So we've got our rocks created. Now let's add another geometry for the creatures. So for the creatures, dive inside. Once again, we'll object merge from the creature flying basic geometry and select the out deforming creatures null. Sometimes inside all of these different working sections of the scene here, environment, rocks, water, creature, etc., I like using a null called render instead so that I always know that I can just point to the render null, but I didn't do that in this case. So we've got the environment, creature, and rocks, and the last one we need right now is for the water. Call this render_water, and we'll dive inside here. Once again, object merge, and point this to object/waterTemp/outWaterTemp. Okay, cool. So we have all of these render objects set up, and let's go to the out context and create a new Redshift render ROP. And this will create both the main Redshift ROP and this IPR here, which we don't really need to mess with or worry about. And on this Redshift ROP, we'll set the render camera to that render cam wide that we set up earlier. And when you're testing out these renders, you'll probably want to turn on this override camera resolution option. For now, maybe I'll set it to quarter resolution while we're setting things up and seeing if everything's working properly. And next we'll go over to the Objects tab, and this setup is similar to Mantra or possibly other renderers as well. If you look at the Mantra ROP, you'll see a very similar set of parameters under the Objects tab, and these work a similar way. So going back to the Redshift ROP, I always leave candidate objects blank. Whenever you're including any of the objects in the scene as candidate objects, that means the render will include anything that has the display flag turned on at the object level here. And we're always changing the display flags of things at the object level, so I don't really want this to affect what my render setups are doing. If I'm working in Houdini and want to change what's being displayed at any given moment, we don't want that to affect our renders. So going back to the out context, always set candidate objects to empty, and then under force objects, sometimes you might want to just include anything that's prefixed with render. So you could do render_star to pull in all of the render objects. But especially as our scene grows a bit more, I don't want to do this. I'll just pick the render objects specifically from the list here, and I'll grab those 4 and accept that pattern. And at some point, we'll start wanting to set up some holdout objects. So there may be elements of the scene that we want to render isolated, like once we add in the destruction here, we'll want to do the dust and a separate render, and we'll want to use matte objects as holdouts. And there are some kind of unintuitive things about the way that matte objects work in Redshift, and we'll take a look at that a little bit later once we start doing some isolated render passes. Another important object type here is this phantom object, and these objects won't be visible in your render, but they will be visible in reflections and refractions and shadows. So for example, if you put a big rock in the middle of the river there, it's not going to be visible itself, but you'll see that reflected in the river water and refracted inside that water as well, and shadowing these surrounding areas. And that can be really helpful. We don't really need that with any of our current render passes right now, but we'll probably add in some phantom objects for some of our renders later on. And similarly to the geometry objects here, we also want to get rid of the star and the candidate lights because we don't want to include all lights that are currently in the scene. We want to be very specific about what lights are included in each render. And because this is an effects class, we're not going to get super deep into elaborate lighting techniques. We're going to mostly be relying on some straightforward environment lighting. And this is one of the classic ways of getting some nice looking renders right away. So if we go back to the object level, let's start adding in some lights here. I'll type RS and select the RS light dome. And these light domes essentially are the same thing as the environment light that's built into Houdini. We're not going to use that right now since we're working with Redshift. And these light domes and environment lights work best when you supply them with HDRI images, high dynamic range images that store values, way above standard white to represent super bright areas. And this will give us a lot more lighting detail in general. So if you go to the light tab, you can find some HDRI images for free online. There's lots of them available if you just do a quick look. You can also look at some of them that come with Houdini by default. So in the standard Houdini locations here, you can go down to Houdini/pick/HDRI. So you can just use one of these if you would like. And different HDRI images will have a massive difference on how your scene looks in the render. So we'll just use this standard Houdini HDRI for the moment and see what that looks like. So let's go back to the out context, and on our Redshift ROP underneath Forest Lights, let's select that RS light dome. And now with all of that set up, we can start running some renders. And you can do your Redshift renders from Houdini's render view here, but I find it much nicer to work with Redshift's own render view, and you can access that on the Redshift shelf and hit this render view button here. And this will automatically start rendering our scene. And this image you're seeing right here is an old render that I was running that has a different HDRI than the one that we've loaded up from Houdini's own HDR directory there. And yeah, now when we do this render based on this texture file that we loaded up from the supplied HDRIs with Houdini, you'll notice that it doesn't look anything like what we're seeing in the viewport. In the viewport, we have this nice landscape, and in our tiny little render preview here, we're not seeing that at all. We're seeing some sort of strange colored background. And if you see this little error message in the bottom of the render view, you can see it says texture processor failed, and that warning is also visible if you middle mouse on the Redshift ROP here. You can see it failed to retrieve dome lighting data from that texture, and it's saying perhaps it's a file format that OpenImageIO doesn't know about. So it looks like perhaps this rat texture format that Mantra likes to use doesn't work well with Redshift perhaps. I always just use EXR images, so we may need to stay away from those rat files that ship with Houdini. There are tools that you can use to convert those, but instead of messing with that, let's just grab an EXR HDRI. And I've already downloaded a pretty nice one. Like I said, you can find tons of these HDR images on the internet, so feel free to play around with some and experiment with different image-based lighting versions. And I have one saved in my textures here. It's this nice little landscape that has a lot of nice lighting contrast in it. And you can see that as soon as we selected a new HDR texture image for our RS Light Dome, it automatically updated our current IPR Redshift render view here, and this is looking pretty cool. Of course, you can experiment with different lighting setups by trying out some different HDR images, and it can also be helpful to go into the transform settings, and you can rotate this image to play around with different lighting directions, which can have a pretty massive difference on the scene. This is looking much brighter just by changing that lighting direction. But I don't really like this quite as much. I like how it was looking before, so I'll set that rotation back to 0. And this scene has been kind of slow for the render to start up and get going. And one of the big reasons that this has been kind of slow to initialize the render and run it is because our rocks are extremely high resolution. So let me stop this render here and minimize that render view. And yeah, if we take a look at our rocks again, these are extremely detailed, very high res. Like I mentioned when we were building the rocks, you might want to create some lower resolution versions of these rocks for shots that are further away. But there's one quick thing that will make this run much faster at render time. And actually, we can also make our viewport respond faster as well, just by turning off the viewport lighting. This will be a lot easier to work with if the viewport starts to slow down too much. And to speed up the render itself, let's go to this geometry node for the rocks. And under the Redshift Objects tab, and under Settings and Instancing, you can turn on Instance SOP Level Packed Primitives. And we set up these rocks as packed disk objects. So yeah, we might have, maybe a couple hundred rocks here. I'm not sure how many we actually have, but there are only a handful of different packed objects being scattered and reused. So by turning on this instancing for those rocks, we'll see a big speed up in how quickly our renders start up and probably how long they take to actually render as well. So by turning on this one option, we cut our render time down quite a bit. The previous renders were running, I think, around a minute and a half, and now we're down to about 30 seconds for this render. So this was an improvement of, I guess that's about 3 times as fast. And I wouldn't necessarily worry about it for something like the creature tentacle segments, because those aren't really dense geometry, but it's definitely helpful to turn that option on for something heavy like these rocks. Now we're going to make some render improvements that I think I'll save for the next video, but there's one more thing I would like to add to this one, and that is going to be adding some lights coming from the creature's eyes. So let's hit this button to stop this IPR rendering here, and we'll minimize that render view. And if we go inside our render creatures geometry object, you can see these little lights on the front of the creature here. Those are going to be used as geometry light sources. And this is one of those really easy ways to just make something look really awesome. I love using geometry lights in general, and they just always look super cool. So to set this up, let's go in this render creatures geometry object. Let's first delete the eyes from this creature. So drop in a blast SOP and display that, and we'll select the eyes group. Actually, it looks like we don't have that eyes group available anymore because we packed these creatures when we put that color on them to display them. So let's go over to where we've set up these flying creatures. And yeah, we have this pack and color. And because we're packing up all of these creatures into one packed object, we don't have access to all of the attributes and groups and etc. So I'm just going to move this out deforming creatures null, and we're going to put that before the pack and the color. So this way, we can still display this node so that we see the darker colored creatures in the scene, but our render setup that's referring to this out deforming creatures null will pull in the creatures when they're, all individual polygons and packed disk objects. So going back to our render creatures geometry object here, and on this blast node, now we can select that eye group. So if you display that, you can see that deletes those eyes from the creature. And we can do essentially the inverse of this to create a geometry object that only contains the eyes. So let's go back up to the object level and copy this render creatures node and paste that in. And I'll call this light creatures and dive inside there. And this has the same, blast node for the eye, but on this one, we'll flip this to delete non-selected. So we have one object that's isolating just the eyes only, and then we can use this with a light source to use that geometry to light the scene. So to keep these things kind of visually organized, I like to make my render nodes red and my lights yellow like this. And we can go ahead and create an RS light. And on this RS light, go to the light tab, and we can leave this set to area light. And under this area section here, we'll set the shape to mesh. And that enables this option to pick a mesh object to use for the light geometry. So let's just select our light creatures object. And the samples will affect the quality and the noisiness of this geometry light. It takes a little bit more computation for Redshift to determine the lighting based on a geometry source like this. So feel free to turn this up if you need to reduce noise. This volume setting is also pretty important. For our current render, we have no volumes in there, but you always need to have a light with a volume contribution in order for volumes to be lit by them. They won't be lit by default. So on both this geometry light, I'll rename this to RS light creatures. I'll set the contribution scale on this to 1. And let's do that on this RS light dome while we're at it. We'll set that contribution scale to 1 as well. And then back on our creature lights, I think all of our settings are fine. Let's maybe turn up the exposure a little bit to make sure that we have some nice bright lights straight away. And I'm also going to create a new camera from my current view here. And you might want to do this when testing out specific portions of the scene. So with, my free perspective camera set how I want it, if you hold Control and click the camera button on the shelf, that will create a new camera here. And I'll just rename this one to Test Cam. And let's go back to our Redshift render ROP. And we can add this creature light to our force lights setting here. Select that one as well and accept that pattern. And I'm also going to temporarily go to the main tab and change this to use our test cam for the moment. And our render's been really small so far, so let's turn this up to half resolution and open up our render view. And let's hit the button to do a new render and see what this looks like. Cool, so this result is already looking kind of interesting. This will look much nicer when we can see this affecting the environment as well. And when we put a darker shader on these creatures, that will also serve to enhance the effects of these geometry lights on the creatures themselves as well. So let's stop this render and let's go to a frame where the creature is closer to the ground. So it looks like frame 152 has this one creature facing the ground pretty close. And let's take a look at what this frame looks like. I'm going to go back to my test camera and click the lock in the viewport. And this will move the actual camera when I navigate in the viewport instead of taking me out of the camera when I navigate. And let's take a closer look at this section. So this is looking pretty cool. It's a very nice lighting effect coming from those creatures on the environment. And this default progressive rendering will sample the entire image. And sometimes it's nicer to have this update the image in specific buckets. So you can turn on this bucket rendering option here. And this is actually very important when we're looking at AOVs later. And we can embed different images in our render that I'll talk more about soon. And I believe those AOVs are only visible in the render view when you set this to use bucket mode. It's kind of a not very obvious thing you have to watch out for. And now if we want to save images in our render view to compare different things that we're experimenting with, you can click this little button here to take a snapshot of your current render. Actually, that will only open up the snapshots. You need to click this one to actually take one. So that's saved this image here. And let's take a look at a couple more settings before we call it a wrap on this video. Going back to the Redshift render ROP, under the Redshift tab, one of the big things that can really make an image look a lot nicer is turning on global illumination. And one of the main things that makes CG renders look fake is this sort of perfect crispness between, the illuminated areas and the shadowed areas. And in real life, we have a lot of light bouncing around the scene. So for example, light rays that enter this little valley here are going to bounce around quite a bit. And if a light ray hits here, then you'll get some amount of, reflected light energy into the surrounding areas. And that's kind of expensive for a renderer to compute, so it won't be on by default. And under the global illumination tab, you can turn this on here. I'll just set both the primary and secondary GI engine to brute force, and you can increase the quality of this global illumination by increasing the number of rays. And you can see now this is drastically changing the look of our image. I'm not going to go too far into tweaking our lights right now to compensate for this, at least not until we get some shaders applied to these objects. But you can see that extra light bounce in the scene is, it's having a massive effect on our image here. You can also see that this is getting very noisy because these light bounces require lots of sampling in order to generate a smooth result. And brute force GI rays will certainly help with this, but it's also dependent on your standard sampling here. So under these sample settings, you can probably leave the min at 4, and the max samples, we can start increasing that. So if we turn that up to 64, we should get a much smoother result. And, we could do an entire course on just optimizing Redshift renders, and that can be a very deep topic. So I'm not going to dive into every possible render setting you might want to play with in Redshift. I'll just focus on these key ones that we're using to get some clean renders. And yes, this max samples increase certainly helped us to have a less noisy image here. And one option that you can use if you just want Redshift to just give you a nice clean image without spending tons of time dialing in the perfect number of samples, is you can go to the System tab and scroll down here to enable automatic sampling. And for big projects, you might want to put a lot of care into dialing in the right number of samples that balances render time versus clean end results. But oftentimes, especially for personal projects like this, it can be a lot easier to just turn on this automatic sampling option and just let this give you clean renders straight away. So you can see that as soon as I turn this on, this is taking a lot longer to render. Especially right now, you can see it's doing this bucket here, and it's taking a really long time because this has a lot more data to compute because it has the proximity to these geometry lights. These other buckets around the sides of the image, these all rendered pretty fast, and this is increasing the sampling more where it's really needed, like these sort of complex geometry light areas. And now, with that automatic sampling, we have a really beautiful image here. This is starting to look quite cool. So for my final renders, I just relied on that automatic sampling, but as you're kind of doing test renders and experimenting with things, especially when you're doing longer frame ranges, you might find yourself wanting to keep this automatic sampling turned off so that you can get your renders through faster. And then the last thing that I'll point out in here, at least for this video, is motion blur. And this is one of the most important things that we need to get things to look realistic. So I'm just going to enable all of the different types of motion blur. And it doesn't seem like that's refreshing our render here. So I'll force a refresh by clicking the little refresh button. And I'm not sure how obvious this will be with our current creature's motion. And if we want to only re-render that portion of the creature, we can turn on this render region selection here. And that'll speed things up by just rendering the area that we're really interested in here. And this addition of motion blur is certainly slowing down our render quite a bit, but it's giving us much more realistic detail by kind of adding that extra bit of blur in here. And I think that's more than enough information for this video. We'll just finish up by zooming in on this area of interest here, and we can compare that to our previous snapshot without the global illumination and without motion blur and without automatic sampling, and click away from that snapshot to see this much nicer image with much more appealing lighting and realistic blur and such.